When you think of nature's most dangerous venoms, you probably picture a creature designed to kill. But what if I told you that some of the most agonizing toxins on Earth aren't meant to kill you at all? They are designed for something much worse, to make sure you never ever forget the encounter. Hello and welcome. Today, we are looking at the 10 most painful venomous creatures on the planet. But we are not just going to list them to scare you. We are going to break down the evolutionary biology behind them. Why do these animals exist? What exactly is happening at a cellular level when you get stung? And most importantly, how is the Western medical community actually using these terrifying toxins to revolutionize modern medicine? If you live in the USA, UK, or Canada, you might think this doesn't affect you. But whether you are hiking in the American Southwest, diving in the Caribbean, or taking prescription painkillers developed in a Boston laboratory, the science of venom is quietly shaping your life. Let's break it down. To understand venom, we have to understand pain. Pain is not a punishment, it is a biological alarm system. When a toxin enters your body, it triggers nociceptors, your nervous system's pain receptors. Evolutionarily, venom serves two distinct purposes: offense and defense. Offensive venom is designed to be quick and efficient, neutralizing prey before it can escape. Defensive venom, however, has a different goal. It doesn't need to kill a predator, it just needs to hurt so badly that the predator learns a permanent lesson. Most people stop here, they should not. Because when we look at the data, we find that the line between offensive and defensive venom is responsible for some of the most complex biochemical warfare on Earth. Let's look at the animals. Let's start with the creatures that use venom purely for defense. If you live in the United States or Canada and hike in the Southwest, you might encounter the Gila monster. It is the only venomous lizard native to the US. It is slow, shy, and spends 90% of its life underground. Its venom is delivered through a painful, lingering bite. There is no antivenom, and while rarely fatal, it causes severe swelling, nausea, and a drop in blood pressure. The pain is a deterrent, meant to teach a coyote or a careless hiker to leave it alone. Similarly, the Arizona bark scorpion relies on defensive pain. It is small, highly camouflaged, and famously glows under ultraviolet light. A sting from this scorpion doesn't usually kill a healthy adult, but it causes 24 to 72 hours of what victims describe as continuous, localized electric shocks. Since 1968, there have only been 2 recorded fatalities in the US, but the sheer agony ensures that whatever stepped on it will never do so again. But here is where the story gets complicated. What if the creature looks entirely harmless? Enter the platypus. Found in eastern Australia, the male platypus has a razor-sharp spur on its hind legs connected to a venom gland. The venom is not lethal to humans, but it causes immediate, devastating pain. And this is the part that changes everything for medical science. Standard painkillers, including morphine, do not work. The venom triggers a condition called hyperalgesia, making the nervous system hypersensitive. In 1991, an Australian soldier named Keith Payne was stung while rescuing one. The pain was so severe he compared it to shrapnel wounds. 15 years later, he was still experiencing chronic pain in that hand. The platypus proves that venom can permanently alter your neurological baseline. Now, let's shift to offensive venom. These animals use toxins to hunt, and the efficiency is staggering. Take the inland taipan in Central Australia. It is widely considered the most venomous snake on Earth. A single bite contains enough toxin to kill 100 adult men or 500,000 mice. It is roughly 70 times more toxic than a king cobra. The venom causes massive blood clotting throughout the body, leading to rapid organ failure. Fortunately, the snake is incredibly shy and lives in remote areas, and we have an effective antivenom. In the oceans, the stonefish and the geography cone snail are masters of camouflage. The stonefish blends perfectly into coral reefs. If you step on it, 13 razor-sharp spines inject a venom that causes pain so severe it can lead to shock and heart failure. The cone snail, specifically the geography cone, hunts using a harpoon-like tooth. Its venom contains conotoxins that instantly paralyze the nervous system. It is so fast-acting that it earned the grim nickname the cigarette snail, implying you only have time to smoke one cigarette before the respiratory paralysis kills you. And then there is the Australian box jellyfish, specifically the Chironex fleckeri. With tentacles reaching up to 10 feet and millions of microscopic harpoons called nematocysts, its venom attacks the central nervous system and the heart simultaneously. A sting can cause cardiac arrest in under 5 minutes. The pain has been described by survivors as being branded with a red-hot iron. The numbers tell a different story about these predators. While their venoms are terrifying, human fatalities are actually quite rare when proper protocols and antivenoms are utilized. The real danger is usually a lack of public awareness. This sounds straightforward. It is not. Because some of the most painful venoms belong to tiny insects that have perfected the art of psychological warfare. In the rainforests of Central and South America, the bullet ant delivers a sting so painful it is rated a 4.0 on the Schmidt Sting Pain Index, the absolute maximum. The pain is described as a firing gun and lasts for a full 24 hours. This is why the Sateramo people of Brazil use them in coming-of-age rituals, forcing boys to endure hundreds of stings. Similarly, the executioner wasp delivers a sting that experts debate as the most painful in the insect world. While some report the pain lasting only 20 minutes, others suffer for a week. Neither insect is naturally aggressive. They sting only when their personal space is violated. Finally, the Sydney funnel web spider. With fangs long enough to pierce a fingernail or soft shoe, its venom causes a massive, uncontrollable release of neurotransmitters. Victims experience muscle spasms, nausea, and tingling around the mouth. Because the antivenom is so limited, Australian facilities actually ask citizens to catch the spiders and bring them in to be milked for venom to produce more antivenom. It is a perfect example of human-animal coexistence driven by science, not fear. So, why does this matter to you in the US, UK, or Canada? First, as global travel increases, citizens from London, Toronto, and New York are frequently visiting these habitats. Understanding the difference between a defensive deterrent and an offensive predator can literally save your life. But more importantly, this is the part that rarely gets reported. Western pharmaceutical companies are mining these venoms to create miracle drugs. Remember the geography cone snail and its paralyzing conotoxins? Researchers in the US isolated a specific peptide from its venom and developed Ziconotide, brand name Prialt. It is a non-opioid painkiller that is 1,000 times more potent than morphine, used for severe chronic pain patients who cannot take opioids. The Gila monster's saliva led to the development of Exenatide, a crucial medication for type 2 diabetes. The Brazilian pit viper's venom gave us captopril, a standard blood pressure drug. Most analysts missed this. Here is why it matters. The creatures we are most terrified of are actually holding the biochemical keys to curing some of our most intractable diseases. When we destroy their habitats, we aren't just losing biodiversity, we are burning down our own pharmacy. The data reveals something most people overlook. Nature's most painful venoms are not mistakes, and they are not malicious. They are highly calibrated, evolutionary masterpieces designed to maintain the balance of ecosystems. The solution is not to eradicate these animals out of fear. The solution is rigorous funding for ecological conservation, public education in high-risk areas, and continued investment in biomedical research. We need to shift our perspective from viewing these animals as monsters to viewing them as highly specialized biological engineers. From the slow bite of a Gila monster to the microscopic harpoons of a box jellyfish, the science of venom is a testament to the relentless, brilliant, and sometimes brutal process of evolution. The next time you hear about a deadly creature, pause and ask yourself, what is the actual biological purpose of its venom? The answer might just change how you see the natural world. I want to hear from you. When you look at the medical breakthroughs derived from these venoms, do you think governments are doing enough to protect these habitats? Or are we losing them too fast? Let me know your thoughts in the comments below. If you found this analysis helpful, please share it with someone who needs to see it, and subscribe for more deep dives into the systems that shape our world. Stay curious, stay rational, and I will see you in the next one.